All right, that sounds great. Okay, so hopefully this technology cooperates with me throughout this. So as Ali said, I'm Kaitlin Hayes. I work with the Agency of Agriculture, and I have been the Vermont Phosphorus Challenge for several years now, which seems crazy when I was putting together this PowerPoint. And so I will give you a brief overview. VPIC is the nickname that we've been referring to the Phosphorus Challenge as. And so I'm going to go through and give you a quick background, just not knowing, folks' knowledge base going into this. And then I will bring you through the timeline, how it got started, who's involved now, and then a little bit more detail on each of the projects that are still involved with VPIC, and then what the timeline looks like moving forward. And as Ali said, if you have any questions throughout the PowerPoint, feel free to ask them. I'll do my best to address them. So this governor's initiative that he with VPIC, and it was looking at, we have an issue with phosphorus in our state, and it does cause some pretty severe impacts to water quality. And, it comes from different sources, and some of which are a lot more expensive to address. And so as part of Lake Champlain's TMDL, agriculture was identified as one of the most cost-effective ways to address phosphorus loading into the lake. And so VPIC was, a couple years later, but is another step that the state has been taking in addition to all of the practices and all of the work that's being done by farmers and folks in all other sectors to address phosphorus. This is another building block, another tool in the toolbox to try to provide a very unusual means of funding that allows for innovation and new creative ways to address some of these phosphorus issues that we are having and have had. Just most folks here probably are painfully aware of the phosphorus imbalance that exists in our state and in many states, many countries, with livestock and agriculture in particular. We tend to buy in a lot of grain and other products that contain a lot of phosphorus that is then taken in on the farms. It's ingested, the cows poop, their manure has a lot of phosphorus in it that's then spread on the fields. And so what happens is with this cycle, there's more phosphorus coming into the state than was here before, than is leaving. We don't have, an internal viable local market at this point yet, and feed a lot of purchase from out of state. And so that's kind of a very brief, very high level overview of the phosphorus imbalance in an agricultural realm that our state is experiencing right now. So VPIC is coordinated by 3 different agencies in the state: the Agency of Natural Resources, the Agency of Ag, and the Agency of Commerce and Community Development. And so these are the folks that have been involved throughout the process, all secretaries, and then Brett Long, who's the Deputy Commissioner of the Department of Economic Development. And they have all been really wonderful and brought different very important insights and knowledge bases to this whole project. So the process for VPIC and the timeline. So VPIC was very different. It wasn't launched as a normal RFP, which is often how states have to advertise to get contracts signed. We were able to do it as more of a reverse pitch. So we said, hey, we have an issue. Can we have folks submit all of their proposed solutions to this issue that we're having in our state? And so we were able to go through those in various stages and select them, get them funded very quickly, which is not usual in state government. And so it was really an innovative way to go about this. So VPIC was first launched in April of 2018. That was when the governor first announced it. And the idea behind VPIC was not just to look at, okay, we have this issue with phosphorus loading. What are some ways that we can address it? Looking at the marketability of reused So that's the commerce and community development side of this, is saying, okay, so we have this technology, it can extract phosphorus from cow manure, but then it can make it into an additional product that then has some resale value or some value on a farm. And so this technology is viable. It could eventually be self-sufficient in the long run. And so that's really what VPIC was looking at, is something that with a little bit of startup funding could then continue and be self-sufficient down the road while still helping Vermont to address the phosphorus imbalance. So initially we had 27 proposals submitted. They were worldwide. We had folks submit from over in Europe, and folks submit from Canada and all the way in the West Coast. And we then narrowed it down to a short list, a group of 16 different proposals that then came and presented in September of 2018 here in the state. And that gave us the ability to see these folks. They gave a presentation about their proposal. And from that stage and from that group of folks, we then selected 6 groups to progress on to stage 2. And so stage 2 in VPIC meant that these groups were allocated a certain amount of funding to work on this business case development and prototyping stage. So this is saying, you have this idea, we think it's viable, let's put a little bit more money into it so we can do some trials, so we can do a bench scale to then see if this is scalable to something that we could implement on a statewide basis. That started in, I think we had the grants out for that in December of 2018, and that lasted throughout the year. And then all of the groups were responsible for submitting a business report, which was, the meat of everything. It included all of their research results, it included trials, it included looking at the business and marketing side of things. Is this going to be something that people will buy? And so those reports were all due in, and from those we selected folks to move on to stage 3. And so stage 3 was this concept of full-scale implementation. We've done the initial work, we've done the bench scale, and now we're looking at this full implementation of these technologies that we can ideally get on the ground, get installed within the next year or two, to then actively be reducing phosphorus in the state. So as you can see, we selected 5 groups in last November, just about a year ago now. And there was over $1 million that were awarded to these 5 different groups. And so I'll go into a little bit of detail about what that means. It wasn't just the 1 million that was released immediately to all the groups. Several of the groups had to do some more research, and some of which is still ongoing, that would then, that research is what the release of the rest of the funding is contingent on. And so I'll talk about that in a little bit here. So we did have a group of folks that helped us evaluate the research report, so it wasn't just internal. And this is a mix of very, very intelligent academic experts, folks that are very savvy in the business field, folks that understand the marketing side of things, that understand how phosphorus works. So it was really wonderful to work with all of these folks, and they volunteered their time to help us with this process. And so we are still very, very grateful for their participation. And so these are our 5 groups that made it to stage 3 and that we are actively working with still. And so I'm going to go through each of these groups and give, a high level overview of what their project is and then where they are right now. So we have DVO. DVO is in Wisconsin. They are for producing anaerobic digesters, of which we have, I think, 9 or maybe 13 in the state right now. And so they were awarded an initial amount of $500,000, and that was our largest award. So this project was looking at taking materials produced from a digester located on dairy farms, putting those materials through a dissolved air flotation or a DAF device, and then being able to use the solids produced through the DAF and separate them into something that is very high in phosphorus, and use that to then be reused in the state as a fertilizer or nutrient additive, whether it was going to be sold as something that's bagged or bottled. but something that had a marketable component to it. And so the pea cake is what we've been referring to as the material coming out of the DAF device. DVO worked very close to them, Dr. Eric Roy, throughout pretty much all stages of VPIC, and looking at this pea cake that was produced from the DAF unit, and saying, how did things grow in it? And so there was a whole research study that was done in stage 2 that looked at the impacts of using the pea cake on crop yields, germination rates. It was really quite extensive and very impressive. And so from that, we came to one kind of gap in this whole process is that, so when the pea cake comes out of the material, this consistency of the material was not ideal to plant, and it wasn't something that you could put in a bag and sell on the shelf. The folks at UVM had to do various kind of drying techniques, and then when it dried, sometimes it was kind of hard. And so that was something that was a gap in this project. And so for stage 3, DVO was initially released $10,000 of the $500,000 to work on this drying method. And so they proposed using quicklime as an additive to the pea cake to dry it in such a way that it would be usable, but not impact crop yield and not impact germination rates. And so, this whole process is where we are right now, and it's still ongoing. If the pea cake can't be dried in a manner that is usable by folks, if it's not something that you can sell as a bulk item or sell as a bagged item, that would really, that does impact the total result of the VPIC project. And so, by the end of the year, we'll have a better idea of where we are at with this particular project. There's some really innovative ways to dry material, and so those are things that are being looked into. But that is where we are at right now, is where we have a really great material, but figuring out how to get it in a cost-effective way to a place that it can be used is where we are at right now with this project. Okay, so moving on to the next one, AgriLab Technologies is based in Enosburg Falls. They were awarded just over $300,000, and so part of that was working on a market and business plan. And what AgriLab Technologies proposed was a hub and spoke composting facility setup. So having something that is some of these slides have quite a bit of text on them. Sorry about that. There's just so much information. So for it's having a hub and spoke type of model. So you would have a hub composting facility like a home farm, and then you would have a certain amount of farms within a calculated distance that would be referred to as spoke farms. And so the idea would be to be able to get the material, the manure, from these spoke farms and either compost them on site or get the manure in a portable device and bring it to the hub facility and then compost it there. And Brian is a composting expert. He's been in this field for a very long time and has projects, down in Massachusetts, already happening in Vermont. And so he worked very closely with the Sustainable Jobs Funds to look at, is there a market demand for these composted products? If we go through this whole process of setting up a hub and spoke model, are we going to be able to sell them once we produce them, and whether that's bulk or in bag items? And so that was the first step. So we worked with Brian, and he was allocated $25,000 initially to work with the Vermont Sustainable Jobs Fund to look at this market demand. And so that was the first couple months of this project. And then in April of 2020, they submitted a market research report that showed that there was a market demand and that it was cost effective and feasible to set up this hub and spoke model. And so AgriLab was released the additional $300,000 to continue with the fabrication and construction of the different pieces of this project. And so that's where we are at. Of course, it doesn't need to be said that COVID has severely impacted every one of these projects in different ways. A lot of the fabrication Brian and his crew have been able to do on their own, but some of the parts have to be sent in, and so there's delays on that. And then it's even, being able to get out there and do the work was delayed for quite a bit as well in the spring and the summer. And so there's different parts of the hub and spoke model. As you can see, this is one of Brian's compost heat wagons. And so this is all part of the, oh, I see there's some questions here. This is all part of the whole setup for Labs hub model. I'm just going to look at what these questions are here. Oh, good question, Vicki. So Vicki had asked about what type of manure is being used. They've been using both kinds, and actually they have a really great relationship set up with one of our other VPIC groups, Digested Organics. And so they've been able to, take liquid manure and separate that out through an ultrafiltration unit, and then use the concentrated portion of that material, which is very high in phosphorus, and incorporate that into the material, the compost material that Brian is using, and make a really valuable fertilizer. And so that's a really great relationship that kind of, they had that before VPIC, and the VPIC, we've just been able to really support that. So I think, let's see if I can get out of this here. Okay, so right now Brian is working on getting all the sites set up. So not only does he have to get the site where is going to be, he also has to get all the spoke sites set up, and those are located up in northern Vermont, around Fairfield and St. Albans. And right now, one of the hardest gaps that they're facing right now is figuring out power. Three-phase power is something that's really crucial for these projects, especially for Digested Organic and their ultrafiltration unit, which they're up next. But making sure that these farms that are not necessarily located in the most ideal place have access to enough power that it's not going to cost the farms a lot of money to be able to have these processes set up and function on the farm. And so these are some of the questions we're still trying to navigate a little bit. I don't think we're full ahead with these projects. It's just kind of a little blip in the road here as we progress. And as you can see, Brian has still been working on his business plan, and we'll have another update from them in December. And so we'll be able to see what the next year is going to look like. Let's see. Looks like it's getting that. Okay, there we go. So next up is Digested Organics, and they're based out in Ann Arbor, Michigan, and they were awarded, over $200,000 for the fabrication and also the operation and maintenance of their ultrafiltration system. So they have been working on this UF system for quite some time. Through VPIC, they've been working on developing a portable system, so something that can be built in a trailer and transported from farm to, hence that'd be something that could be used on the spoke farms to separate out liquid dairy manure into something that's very concentrated phosphorus, and then something that is referred to as the T liquid, this remaining liquid that's very low in phosphorus that farms can apply on fields without significantly increasing the phosphorus levels in their soils on those fields. So you can see in the picture here, this is the concentrate and the tea water separated out, and you can tell which one is which there. But right now, they have Digested Organics has the design for the whole system ready, and they've been working on the fabrication of the modules. So this portable unit is made, they have some larger units that have been installed and are operational in different parts of the country, but this portable unit is meant for a Vermont-sized farm. It's right, this one is built for about 100 cows, and it can process about 3,000 gallons per day of manure. And that's something that we can use in the state. It's not so small that it, it's not going to be effective on addressing phosphorus, but it's also not so large that it's cost prohibitive for smaller farms to be able to either, rent, or maybe a group of farms purchase this type of technology. And that's kind of the idea behind this, this type of unit. So as you can see, they'll be going to these different sites and separating the manure, and then the concentrate can be taken to one of AgriLab Technologies composting sites and incorporated into there, and that will create a really great compost that's can be used hopefully by farms in the state, but also by other types of agricultural users, whether that's home gardening or specialty crops, hemp farmers, anything like that. These products will be available and desirable by lots of different folks is the idea. So they have the trailer pretty much ready to go at this point, was the last update that I got. It should be able to be transported here by the end of the year. Again, the delays with COVID may postpone that a little bit, but this project's in a really good place, and it's really exciting to see the progress that they've been making. All right,
Kaitlin,
so up next.
And that question was, can you go into why the concentrated product decreases soil phosphorus?
Oh, sure. So, so the concentrated phosphorus does not decrease the soil phosphorus. So the idea is that a farm that has liquid manure can use this ultrafiltration device, and they can put the material through the device, and it will separate out this concentrate, and then what's left over is this tea water that's very low in phosphorus. And so the issue that a lot of farms have, especially ones that have liquid manure, because those tend to be larger farms, is they don't have storage capacity. And so they really need to get the manure out of their pits and onto the fields. But some fields are very high in soil phosphorus. And so they can't go and just spread normal manure on it, because that would leach or potentially run off and whatnot. So the idea is that with this tea water, which is very low in phosphorus, farmers can go and spread that on fields, and it won't significantly increase their phosphorus index reading on those fields. And then what they can do, because a lot of farms actually do have a lot of fields that are phosphorus deficient, but transporting manure is a huge hurdle, and that's a whole nother webinar that we could talk about. But with it concentrated in such a way, there's less of it that needs to be applied, so it's more feasible for farmers to take that concentrate out to some of their further fields where maybe their crop yields are suffering, and make some improvements there. So I hope that answers your question a little bit. The concentrate is not being applied on where there's high phosphorus levels. Okay, so our next group is a partnership, and that is UVM working with the Village of Essex Junction, and then also CSWD and Efficiency Vermont. And this project is a little bit different from our other ones, and it focuses on wastewater treatment facilities. Of all the projects, this is the one where the technology is definitely above my head. And so if there are further questions in this, I will be directing to Professor Raju at UVM. But so struvite is something that wastewater treatment facilities are often battling the precipitation of. When it forms in pipes, it can be really harmful. And so they're often trying to fight and prevent that from generating. What Professor Raju was able to develop was this P-flow technology that actually precipitates struvite in a closed system, which can help remove phosphorus from wastewater streams. And now, wastewater streams aren't one of the sectors that the state is as concerned about for phosphorus contributions to surface waters. But for wastewater treatment facilities, they do have a lot of infrastructure that needs to be updated, and it's very, very expensive. And so what this technology can do is give wastewater treatment facilities an opportunity to install a technology like this that meets the standards for these facilities at a reasonable cost, that then can give them some time before they have to do a full upgrade of a lot more of the infrastructure. So it saves a lot of money for the wastewater treatment facilities and for taxpayers as well. But it also is really beneficial at capturing the phosphorus that is present in these systems also. So this technology does exist in some in a similar manner, but it's on much larger scales. And so what Dr. Raju has been able to do is develop this again on a Vermont-sized scale in a system that could potentially be portable and then be transferred to different wastewater facilities around the state, regardless of size. And that would be really huge for our state. Right now, it's at the Essex Junction wastewater treatment facility right now. And this, because of all of the research and all of the work that was being done at one of the UVM labs, the lab was totally shut down for a large portion of the spring and for a large portion of the summer. So they're a little bit behind where they think that they wanted to be at this point in time, but still are making pretty great strides in terms of focusing on the scalability of the project. So on a bench scale, the technology was able to work and generate struvite. And now it's just a process of getting the equipment, getting the infrastructure set up to make it a little bit bigger, see that it still functions effectively, and then be able to bring it up to the full size. So this project right now is waiting on a couple pieces of equipment, a mixer to be delivered, and after that they will be able to finish doing these pilot testings and then do a full scale up. All right, and so our last participant is Green State Biochar, and they're based in Barton, Vermont. And so Green State Biochar is a current producer of regular biochar, and they also are focusing on producing an enriched biochar. And so that is biochar that has had some sort of either manure or other product go through it that has allowed the biochar to absorb phosphorus. And so you have a biochar product which already has been shown to have some beneficial impacts when applied on fields, but now it also can have phosphorus attached to it as well, which can serve as a fertilizer for crops. And again, because biochar is solid and it's light, it's a lot easier to transport than liquid manure, and so that's another benefit for farms to be able to use a product such as this. So Green State Biochar has their own pyrolysis unit that they built to create biochar. And so the next step of their project has been looking at developing a filter device that can be attached to the end of that's coming out of milk or some kind of barn to filter those waste streams through the biochar, and then use that biochar, that enriched biochar, and either have the farm be able to use that on his fields, or Green State Biochar could purchase back that product and again sell it on public marketplace as a Vermont-based fertilizer, and again for specialty gardeners or small-scale farms as well. So biochar it's been around a very long time. There's still a lot of research being done on consistency of biochar and the reproducibility of the chemical makeup of biochar. This is what I've learned a lot about through this process. And so there's one of our VAAFM engineers, Matt, has been working with the Center for an Agricultural Economy. One of their folks, Celine, and Green State Biochar have all been working together to develop a test to look at if we use biochar in these filtration devices, is it capturing as much phosphorus as other materials that are generally used in similar types of devices, such as septic sand? And is it cost effective? Is it working? And then what is the breakdown of putting this material in, taking it out, and then potentially reselling it or having the farms be able to use it, which would then allow them to not have to buy additional fertilizer. And so this has been an ongoing project, and again has experienced delays due to COVID. And so we were kind of just getting all the results in from the market and business research that was done for this project, in addition to these field and bench trials. So Green State contracted Atlantic Corporation to help them with doing a market research analysis, and we just this weekend received their final report, and so that will be very exciting to look into. So Green State, similar to AgriLab and similar to DVO, was awarded an initial amount of $25,000 to do the whole market research and do some of this scientific research to be sure, what's being captured. And so the release of the additional funding, similar to the other two projects, is dependent upon the results of those reports. And so that will be decided by the greater VPIC evaluation team by the end of 2020. So that's most of the information I had about digging into. So if other questions or whatnot, or I can go back to slides if people want to read more of the text, just let me know.
So Kaitlin, it looks like there is a question in the chat. It's breaking up on my end, so it would be best if you just summarize them.
Okay, so I'm seeing Vicky's question here. Does the market research show that this technology, any of the farm-based projects you have highlighted, can pay for itself, or there will be a need for state federal funding for the equipment to make it viable economically? Yeah, absolutely. So I would say at this point in time, AgriLab, Digested Organics, and the UVM's project are projects that the state determined that they will be able to be self-sufficient and economically viable. I mean, we've provided funding for those, but there's not any additional funding going to any of these projects. So it's, all of those projects have done a lot of work to crunch numbers to make sure that they can stay afloat before they spend all this time and money constructing and fabricating items. They've put a lot of time into the budgets and people's willingness to pay for something that's locally produced, similar to thinking about people paying for any other local product, whether it's meat or veggies or anything like that. And so I am really excited about these projects. I think with DVO and Green State, we're still just waiting to see and analyze the results and the numbers to be able to make that call. But yes, these three projects should be able, fingers crossed, COVID doesn't have any, further impacts that would be, the final acts, but they should be able to be self-sufficient and function. Is the state thinking about a challenge for those proposing farming systems that do not rely on grain and pea fertilizers at the levels of traditional farming approaches? Yeah, I think I understand your question, John. So At this point in time, there just isn't funding available for any other challenges like this. I mean, we kind of were able to sneak VPIC in. Well, I wouldn't say sneak it in. I mean, we had funding that was allocated for this, and then COVID hit, and so there's just not funding available for other projects right now. Hopefully in the future we'll be able to offer more projects like this. There was certainly a lot of interest, and even once VPIC started all the way up through now, we have folks that, you know, reach out with really amazing, fantastic, innovative ideas. And I think offering something like what you're mentioning, John, moving away maybe from you know, some traditional farms that are on this grain pea fertilizer cycle, and providing, you know, some funding to promote innovation there. I think we would love to do that. It's just going to be a matter of, you know, when will COVID allow us to focus on innovation again. Let's see, Myra had a question. What's the final date to roll out a product from one of these projects? Yeah, great question. Hard to say at this point. AgriLab and Digested Organics, on their original schedule in spring of 2021, were thinking that they might have some products they'd be able to test. So caveat, of course, of COVID delays, but they're very well on their way, and they've been, you know, working really hard to set up the infrastructure, and, you know, making sure that the process can run smoothly and be streamlined. Both, you know, Bobby and Brian are very thoughtful in that way. So hopefully spring of 2021, if not maybe later in that year. Let's see, Vicky had another question. Oh, a statement. Yeah, if we support locally grown grain, dryers, and storage, we might be able to get a handle on the decrease in the importation of pea from other states. Yeah, very much so. Very true. Yeah, so we just had a comment looking at you know, some of the other impacts for materials that are important parts of these projects, and it's a very good comment. We've certainly discussed that, and that's, you know, the use of quicklime with DVO, and then producing biochar as well in terms of, you know, global warming and CO2 emissions, and those are certainly things that are taken into account. You know, again, there's a whole equation for each of those different projects that's unique and can be, you know, thought through and calculated. You know, but the biochar that Green State is making is using all scrap wood produced in Vermont, and so yes, there is CO2 produced from you know, the pyrolysis process happening, but there are a lot of steps being taken on both the back end and the front end of things to address CO2 emissions in other ways. But your point is very well taken, Angie. There's, you know, a lot of things to think about when you are assessing the overall impact. Yeah, welcome.
Okay, any other questions for Kaitlin? All right. Well, thank you so much, Kaitlin. And did your last slide have your contact information?
Yes.
Okay.
Let me get down there. Yeah, so if anyone has follow-up questions or is curious to speak to the folks that are, you know, the brains behind each of these things, feel free to reach out. And all of the folks involved are, you know, as I said earlier, intelligent and wildly innovative, and so they would welcome questions.
Well, thank you, Kaitlin, and thank you everybody for joining us today. I will be sending out the link to the Zoom recording via the Vermont Ag Water Quality Partnership listserv, along with the 2 previous recordings we've done. And so also the next webinar that's coming up is Wednesday, December 2nd. Meredith Albers, who is a soil scientist with NRCS, is going to be joining us to talk about NRCS's work and what she does. So we hope to see you then, and thank you all so much.
Wonderful. Thank you all. Take care.